depends on something called Chance Impedance Amplifier, TIA. And we have the circuit right here. So what is this, red triangle here? What is this red triangle? Okay. Okay. It has two inputs. What are these called? The plus side is called the non-inverting terminal. The negative side is called the inverting terminal. And it has an output. So what is in this circuit? So you have your photodiode, and then the anode can be connected to a bias voltage. It can, which can be 0 or a voltage greater than 0. So that puts your photodiode into reverse bias mode. Then then the cathode of this photodiode is connected to the the inverting terminal, the op-amp. Then the non-inverting terminal of the op-amp is connected to ground. So then between your inverting terminal and your output, we have a resistor and we have a capacitor here. So first, let's try to figure out what the output voltage is. All right. So let me ask you this question. What's the voltage here at the inverting terminal? What is the voltage here? Think about the property of an op-amp. So what is the voltage right here? We know that the non-inverting terminal is connected to ground. So what's the voltage at the inverting terminal?
-0.
Which is 0.
Yeah.
Okay, this is 0. Because op-amps have a property called virtual short. Something called virtual short. That means it looks like the two terminals are shorted together. Okay, the voltage here is 0. Then what is the current into this terminal?
0 then.
0.
Yeah.
Why is 0?
Because there's no voltage, so it's not.
Okay. Yeah, it's 0 because the input impedance of op-amp can be considered infinite. So there's no way current can go into an op-amp. So the current into op-amps is always 0. 0, 0. Okay. Okay, then let me ask you, what's the voltage that is flowing across your RF? What's the current flowing into your RF? So we know the photocurrent here is IPD. This is your photocurrent. Then what is the current of your resistor here? Also IPD. Oh. Because your current is going this way, and there's no current into your op-amp. So the current of your resistor is IPD, so that gives your output voltage. So for our microcontroller, the Vout has to be, let's say, smaller than 3.3 volts. And you typically have a photocurrent of maybe around 10 microamps for some. A photodiode, so that gives you your resistor value. Okay, and then there's a capacitor here. This capacitor is for stability. It's used to suppress noise, and this is way too deep for in circuit theory. So I'll just give it to you. So your CF will equal this where the denominator is your input capacitance. And in the denominator, we have 2 pi RF, which is your resistance, and GBP, which is your gain bandwidth product. So all these parameters can be found in datasheet. You can find all these values. So by using these two formulas, you should be able to design your TIA. Datasheet. All right. So are we good to move on? I know, I didn't go very deep into this, but based on information from the datasheet and based on these two formulas, you should be able to design your TIA in your lab. So the next part is